Section A. 1. Quetzal, explain briefly the hydrostatic pressure over a wall surface. Answer: hydrostatic pressure is the pressure exerted by a fluid at rest due to the force of gravity. When applied to a wall surface, such as a dam or retaining wall, hydrostatic pressure increases with depth and acts perpendicular to the surface of the wall. Key points. Formula: P equals ρgh, where P equals hydrostatic pressure, ρ equals density of the fluid, g equals acceleration due to gravity, h equals depth of the fluid above the point in question. Distribution: the pressure is zero at the surface of the fluid and increases linearly with depth. Resulting force: the total force due to hydrostatic pressure acts horizontally on the wall and is centered at 1/3 the height from the base of the fluid surface. This pressure must be carefully considered in structural design to prevent wall failure or collapse. 2 Quetzales, what are the considerations to be adopted while storing and transporting the cement? Discuss. Answer: proper storage and transportation of cement are crucial to maintaining its quality and preventing deterioration. Cement is highly sensitive to moisture and environmental conditions, so the following considerations should be adopted. 1. Protection from moisture. Storage: cement should be stored in a dry, moisture-free environment to prevent hydration before use. Containers: use waterproof and airtight containers or sealed bags. Elevated platform: store cement bags on raised platforms, example wooden planks, to avoid contact with damp floors. 2. Ventilation. Store in a well-ventilated area to reduce humidity but avoid direct exposure to moist air. Avoid storing cement in basements or locations prone to dampness. 3. Stacking and handling. Height limit: stack bags no more than 10 bags high to avoid lump formation due to pressure. First in first out, FIFO: use older stocks first to minimize the risk of cement becoming stale. Covering: use plastic sheets or tarpaulin to cover the stacks, especially if stored outdoors temporarily. 4. Duration of storage. Avoid long-term storage. Cement ideally should be used within 90 days of manufacture. If longer storage is necessary, test the cement for setting time and strength before use. 5. Transportation considerations. Weather protection: use covered vehicles to shield from rain or high humidity during transport. Sealed packaging: ensure bags are not torn and are tightly sealed. Gentle handling: handle bags carefully to avoid damage and spillage. 6. Type of cement. Some types of cement, example quicksetting or high alumina cement, may have special storage needs due to higher reactivity. Conclusion. Proper storage and transport of cement help in maintaining its strength and quality. Neglecting these precautions can lead to significant material loss, structural failures, and increased construction costs. 3 Quetzales, what do you understand by contour interval? Explain the factors that should be considered in choosing contour interval. Answer: a contour interval is the vertical distance or difference in elevation between two consecutive contour lines on a topographic map. It represents how much the elevation changes as you move from one contour line to the next. Factors to consider when choosing contour interval. Scale of the map. Larger scale maps, example 1:1,000, cover smaller areas with more detail, so a smaller contour interval is suitable. Smaller scale maps, example 1:50,000, cover larger areas with less detail, so a larger contour interval is used to avoid clutter. Nature of the terrain. Flat terrain, use small contour intervals, example 0.5 m or 1 m, to capture subtle changes in elevation. Hilly or mountainous terrain, use larger contour intervals, example 5 m, 10 m, or more, to clearly show steep slopes and avoid overcrowding of lines. Purpose of the survey. Engineering projects, example road, dam construction require small contour intervals for accuracy. General geographic or thematic maps can use larger intervals as detailed elevation is not critical. Accuracy of the instruments. The precision of surveying instruments or data sources, example GPS, total station, LiDAR, can affect how small an interval can be meaningfully represented. Map size and readability. The interval must allow the map to be easily read and interpreted. Too many contour lines can make a map confusing, while too few may oversimplify important elevation changes. Conclusion. Choosing the right contour interval is crucial for accurate and useful topographic representation. It depends on the map's scale, the terrain's nature, the survey's purpose, and the need for clarity and detail. 4 quetzales, right difference between one-way slab and two-way slab. Answer, here is a clear comparison between one-way slab and two-way slab. Aspect. One-way slab. Two-way slab. Load distribution. Load is carried in one direction only, shorter span. Load is carried in both directions. Support condition. Supported on two opposite sides only. Supported on all four sides. Slab ratio, Lx/Li. Longer span is more than twice the shorter span, Lx/Li2. Longer span is less than or equal to twice the shorter span, Lx/Li less than or equal to 2. Main reinforcement. Placed in shorter direction only. Placed in both directions. Deflection. More deflection compared to two-way slab. Less deflection due to better load distribution. Construction cost. Generally cheaper due to simpler design. More expensive due to more reinforcement. Common usage. Used in narrow rooms, corridors, or verandas. Used in large rooms, halls, or commercial buildings. Summary. Use a one-way slab when the slab is long and narrow. Use a two-way slab when the slab is nearly square or square and supported on all four sides. 5 quetzales, drawing hydraulic grade line, HGL, and energy grade line, EGL, differentiate pipe flow and open channel flow. Answer. Hydraulic grade line, HGL, represents the level to which water would rise in a piezometer connected to the pipe. It indicates the pressure head plus elevation head, no velocity head. HGL equals Z plus P gamma. Energy grade line, EGL, represents the total energy head, elevation plus pressure plus velocity head, in the system. EGL equals Z plus P gamma plus V2/2G. In a drawing, EGL is always above or equal to the HGL. In open channel flow, HGL equals water surface. In pipe flow, under pressure, HGL is below or above the pipe, depending on pressure. Diagram illustration. Difference between pipe flow and open channel flow. Aspect. Pipe flow. Open channel flow. Flow condition. Completely enclosed with flowing under pressure. Flow with a free surface, under gravity. Driving force. Pressure difference between pipe ends. Gravity and slope of channel bed. Hydraulic grade line. May be above or below the pipe. Coincides with water surface. Energy grade line. Lies above HGL due to velocity head. Also above water surface due to velocity head. Cross-section shape. usually circular. Various shapes, rectangular, trapezoidal, etc. Examples: water supply pipes, closed conduits. Rivers, canals, sewers with free surface. Summary: HGL shows pressure-related energy, Z plus P slash gamma, EGL shows total energy, Z plus P slash gamma plus V superscript 2 slash 2G. Pipe flow is pressurized and fully filled, while open channel flow flows under gravity with a free surface. 6 Quetzales, calculate shear force and bending moment of a simply supported beam in both end of length L, M, with uniformly distributed load of W, Kn/m. Show shear force and bending moment in a diagram. Answer: let's calculate and diagram the shear force, SF, and bending moment, BM, for a simply supported beam of length L meters, subjected to a uniformly distributed load, UDL, of Wkn/m over the entire span. Step 1. Support reactions. For a simply supported beam with a uniformly distributed load over the entire span, the reactions at the supports, A and B, are equal. RA equals RB, equals 1/2 cap W dot cap L, in Kn. Step 2, shear force calculation. At A, X equals 0. SFA equals plus WL/2. At midpoint, X equals L/2. SF equals WL/2 WL/2 equals 0. At B, X equals L. SFB equals WL/2. Shear force decreases linearly from plus WL/2 at A to WL/2 at B. Step 3, bending moment calculation. At A and B, X equals 0 or X equals L. BMA equals BMB equals 0. At midpoint, X equals L/2. B max equals cap W cap L over 2 asterisk operator cap L over 2 numerator, cap W. Open paren cap L over 2, close paren. Open paren cap L over 2 close paren and numerator, over 2. Equals WL2/4 WL2/8 equals WL2/8. The bending moment diagram is parabolic, peaking at the midpoint. 7 Quetzales, what is the purpose of leveling in survey? Describe methods of leveling with suitable sketches. Answer: purpose of leveling in surveying. Leveling is a branch of surveying that determines the relative height or elevation of points on, above, or below the Earth's surface. The main purpose is to establish points at a given elevation, determine height differences between points, create contour maps, design and construct roads, canals, buildings, etc. Objectives of leveling: to find the elevation of different points with respect to a common datum, usually mean sea level. To establish a level surface for construction works. To determine slopes or gradients for proper drainage. Methods of leveling. 1. Direct leveling, spirit leveling. This is the most common and accurate method. It uses a leveling instrument, like a dumpy level or automatic level, and a leveling staff. Procedure: site is taken from the level to a graduated staff held vertically on the ground points. Types: simple leveling, when the instrument is placed between 2 points. Differential leveling, when points are at a great distance or with large elevation difference. Sketch. 2. Trigonometric leveling. Used when the elevation is calculated by measuring vertical angles and horizontal distances using a theodolite or total station. Formula: H equals d tan, theta. Where H equals elevation difference, d equals horizontal distance, and theta equals angle of elevation/depression. Sketch 3. Barometric leveling. Based on the change in atmospheric pressure with elevation. It's a rough method, used in exploratory or reconnaissance surveys. Instruments, barometer or altimeter. 4. Stadia leveling. Uses a tachyometer to determine distance and elevation indirectly by reading staff intercepts. Less accurate but useful for topographic surveys. Conclusion. Leveling is essential for all types of civil engineering works and infrastructure planning. Direct leveling is the most widely used method due to its simplicity and accuracy. Other methods like trigonometric and barometric leveling are used based on the project's scale and required accuracy. 8. Quetzales, what is the relation between dry density and moisture content of soil? How is maximum dry density derived in the laboratory? Explain with the help of suitable figure. Answer. The dry density of soil is inversely related to its moisture content, reaching a maximum value at a specific moisture content called the optimum moisture content, OMC. The maximum dry density, MDD, is the dry density achieved at the OMC. This relationship is typically visualized with a compaction curve, where dry density increases with moisture content up to the OMC and then decreases with further increases in moisture. Relationship between dry density and moisture content. Initial increase. As moisture content increases from a dry state, the dry density initially increases. This is because water helps to fill the voids between soil particles, allowing them to pack more tightly. Peak, maximum dry density. The dry density reaches a peak at a specific moisture content, known as the optimum moisture content, OMC. This is the point where the soil is compacted to its highest possible dry density. Subsequent decrease. Beyond the OMC, further increases in moisture content lead to a decrease in dry density. This is because the excess water lubricates the soil particles, making them less cohesive and hindering further packing. Determination of maximum dry density in the laboratory, Proctor test. The Proctor test is a standard laboratory method used to determine the MDD and OMC of a soil. The general procedure involves the following steps. 1. Soil preparation. A 3 kg air-dried soil sample is prepared. 2. Moisture addition. Water is added to the soil in increments, ensuring thorough mixing and covering with a wet cloth for 15 to 30 minutes. 3. Compaction. The soil is compacted into a standard mold in 3 layers, each layer being compacted 25 times with a standard hammer. 4. Moisture content and dry density determination. After compaction, the mold is weighed, and the wet density is calculated. The moisture content of the compacted soil is also determined, and the dry density is calculated using the wet density and moisture content. 5. Curve plotting. This process is repeated with different moisture contents, and the results are plotted on a graph with moisture content on the x-axis and dry density on the y-axis, creating a compaction curve. 6. MDD and OMC identification. The maximum dry density and the corresponding optimum moisture content are determined from the compaction curve, as the point where the curve reaches its highest point. The Proctor test is a crucial tool in geotechnical engineering for evaluating the compaction characteristics of soils and ensuring proper compaction in construction projects. Fig. Standard Proctor test. Section B. 9. Quetzales. How are roads in Nepal classified as per Nepal Road Standard 2070? Write down. Answer. As per the Nepal Road Standard 2070, 2013, roads in Nepal are classified based on their function and administrative importance. The classification system helps in planning, design, construction, and maintenance of the road network. Classification of roads in Nepal, NRS 2070. A. According to functionality. National highways, NH. Major roads that connect the capital with other major cities and international borders. Serve national and international traffic. Identified by prefix H, example H01, East-West Highway. Feeder roads, FR. Connect district headquarters, major economic centers, and regional facilities to national highways. Identified by prefix F, example F052. District roads, DR. Provide access within districts and connect villages and rural municipalities to feeder roads or national highways. Urban roads, UR. Roads within municipal boundaries, facilitating urban traffic. Village roads, VR. Local access roads in rural areas, connecting settlements, farms, and community centers to the main network. B. According to administrative authority. Strategic Road Network, SRN. Includes national highways and feeder roads. Planned and managed by the Department of Roads, DOR. Backbone of the national transport system. Local Road Network, LRN. Includes district, urban, and village roads. Managed by local governments, municipalities and rural municipalities. Summary table. Type of road. Abbreviation. Managed by. Purpose. National Highway. NH/H. Department of Roads. National/international connectivity. Feeder road. FR/F. Department of Roads. Connect districts/economic centers. District road. DR. Local government. Intradistrict access. Urban road. UR. Municipalities. Within cities. Village road. VR. Rural municipalities. Local rural access. This classification helps Nepal systematically develop its road infrastructure in line with economic development and population needs. 10 Quetzales, what are the purposes of a septic tank? Illustrate the main components of a septic tank with a schematic diagram. Answer, purposes of a septic tank. A septic tank is an underground wastewater treatment structure commonly used in areas without centralized sewer systems. Its main purposes include primary treatment of wastewater, separates solids, sludge, from liquid waste, effluent, allows solids to settle and oil/grease to float, anaerobic digestion, promotes bacterial decomposition of organic matter in an oxygen-free environment. Reduces volume of sludge and odors. Storage. Temporarily holds solid waste for periodic removal, pumping. Effluent discharge. Partially treated liquid effluent is discharged to a soak pit or leach field for further treatment by soil percolation. Main components of a septic tank, with schematic diagram. Here is a labeled schematic diagram followed by descriptions of each component. Main components explained. Inlet pipe. Carries wastewater from the house to the septic tank. Inlet and outlet baffles. Directs the flow of wastewater and prevents scum or solids from entering or leaving the tank too quickly. Scum layer. Composed of oils, grease, and lighter materials that float on top. Liquid effluent layer. The partially clarified liquid zone in the middle. Sludge layer. Settled solid waste that accumulates at the bottom. Outlet pipe. Discharges the treated liquid to a soak pit or leach field. Access cover. For inspection and sludge removal. 11 Quetzales, why is tender notice published and what are the information needed in a tender notice state? Answer: a tender notice is published to invite bids from contractors, suppliers, or service providers for the execution of public or private works, procurement of goods, or services. Its main purposes are: transparency, ensures openness and fairness in public procurement. Competition, encourages competitive bidding, which leads to better pricing and quality. Equal opportunity, provides all eligible bidders an equal chance to participate. Legal compliance, meets the requirements of procurement laws and regulations. Information needed in a tender notice. A standard tender notice must include the following essential details. SL No. Information. Description. 1. Tender number and title. Unique identifier and name of the project or procurement. 2. Employer/client name. Name of the organization issuing the tender. 3. Description of work/good/service. Scope and nature of the work or materials required. 4. Estimated cost, if applicable. Approximate cost of the project. 5. Bid security, earnest money. Amount and form of bid security required. 6. Eligibility criteria. Requirements for bidders, license, experience, financial status, etc. 7. Tender fee. Cost of obtaining tender documents. 8. Date and time of submission. Deadline for submitting the bid. 9. Bid opening date and venue. When and where the bids will be opened. 10. Document availability. Where and when the tender documents can be obtained. 11. Contact information. Address, phone, and email of the responsible authority. 12. Other instructions. Any additional terms, conditions, or procedures to be followed. What is the purpose of technical specification in a contract? Mention. Answer. Technical specifications are a crucial part of a construction or procurement contract. They define the exact requirements, standards, materials, workmanship, and methods to be followed in executing the work or delivering the goods/services. Main purposes. Ensure quality and standards. Establish the minimum quality of materials, workmanship, and performance expected. Clear scope definition. Specify what is to be done, how, and with what materials, leaving no room for ambiguity. Basis for evaluation. Serve as a benchmark to evaluate compliance during execution and inspection. Avoid disputes. Minimize misunderstandings between client and contractor by clearly stating expectations. Aid in cost estimation. Provide detail that helps bidders estimate resources, cost, and time accurately. Compliance with codes and laws. Ensure that the work adheres to national or international technical standards and legal requirements. Measurement and payment. Help define the method of measurement and payment terms for completed work. 13 Quetzales, describe the advantages of the weir and barrage of irrigation structures. Answer. Weirs and barrages are hydraulic structures built across rivers to divert water for irrigation, power generation, and other purposes. Both serve similar functions but differ slightly in structure and operation. 1. Advantages of a weir. A weir is a low, fixed crest structure across a river that raises water levels upstream for diversion. Advantages. Simple design and construction. Easier and less expensive to construct compared to barrages. Low maintenance. Fewer mechanical components, resulting in lower maintenance needs. Suitable for small rivers. Ideal for regulating flow in smaller rivers with consistent discharge. Sediment control. Can be designed to trap sediments, improving water quality. Passive operation. No need for gates or mechanical parts, water flows naturally over the crest. 2 advantages of a barrage. A barrage is a gated structure with adjustable sluice gates built across a wide river to control water levels more precisely. Advantages. Precise flow control. Gates allow real-time regulation of upstream water levels and downstream flow. Higher efficiency in diversion. Better suited for large rivers and seasonal flow variations. Flood control. Can help regulate floodwaters by adjusting gates. Multipurpose use. Supports navigation, irrigation, and sometimes hydropower. Less head loss. Compared to dams or high weirs, barrages cause less change in elevation, maintaining river ecology better. Year-round operation. Reliable water diversion during both low-flow and high-flow conditions. 14 Quetzales, what are the methods of curing of concrete? Write down. Answer, curing is the process of maintaining adequate moisture, temperature, and time to allow the concrete to achieve its desired strength and durability. Proper curing is essential to prevent drying, cracking, and strength loss. Common methods of concrete curing. 1. Water curing. Description, involves keeping the concrete surface continuously wet. Types. Ponding, water is stored on flat surfaces, example slabs. Sprinkling, water is sprayed at intervals to keep surface moist. Wet coverings, burlap, hessian, or mats soaked in water are placed on the surface. 2. Membrane curing. Description, a sealing compound is applied to prevent water evaporation. Materials used, liquid curing compounds like wax, resin, or plastic film. Suitable for large areas and hot weather. 3. Steam curing. Description, steam is applied in a controlled environment to accelerate curing. Used in precast concrete industries. Advantage, rapid strength gain. 4. Curing by covering. Description, concrete is covered with impermeable sheets, example polythene, to retain moisture. Application, especially useful in windy or dry climates. 5. Curing by infrared or electrical heating. Description, heat is applied electrically or using infrared lamps to aid curing. Use, in cold weather conditions. 6. Self-curing, internal curing. Description, special admixtures or materials, like lightweight aggregates, are used to retain water within concrete itself. Benefit, useful where conventional curing is difficult. 15 Quetzales, discuss and explain the process for estimating the quantity of sanitary sewage. Answer, sanitary sewage is wastewater originating from domestic activities like bathing, cooking, washing, and human waste discharge. Estimating its quantity is essential for the proper design of sewer systems, wastewater treatment plants, and sanitary infrastructure. Process for estimating quantity of sanitary sewage. The process involves several key steps. 1. Determine the population to be served. Estimate the present and future population using census data and projected growth rates. Design periods typically range from 15 to 30 years. 2. Estimate the per capita water consumption. Average domestic water usage per person per day. In Nepal, typical values range from 100 to 135 liters per capita per day, LPCD, depending on urban or rural setting. Generally, 112 LPCD is considered in design. 3. Apply a sewage generation factor. Not all water consumed becomes sewage, some is lost via evaporation, gardening, etc. Generally, 80%, 90% of water supply is assumed to become sanitary sewage. Sanitary sewage equals per capita water supply times 0.8 to 0.9. 4. Calculate total sewage quantity. Total sewage, liters/day, equals population times per capita sewage. Convert to m superscript 3/day by dividing by 1000. 5. Consider peak factors. Peak sewage flow is higher than average due to variations in usage. Use a peaking factor, typically 2 to 4, depending on population size. Peak flow equals average flow times peaking factor. 6. Include additional contributions. Add contributions from commercial and institutional establishments. Industrial discharges, if applicable. Infiltration and inflow, groundwater, stormwater entry, often 10 to 15% of total flow. 16. Quetzales, explain site distance and factors causing restrictions to site distance. Explain the significance of stopping, intermediate, and overtaking site distance. Answer: site distance is defined as the actual distance along the road surface which a driver sitting at a specified height in a vehicle can see object either moving or stationary, on the road surface. It is crucial for safe driving operations, allowing a driver to see and respond to road conditions, obstacles, or hazards in time to avoid accidents. Types of site distance. Stopping site distance, SSD. Intermediate site distance, ISD. Overtaking site distance, OSD. Factors restricting site distance. Factor. Effect on site distance. 1. Vertical curves. Humps, crest curves, reduce forward visibility. 2. Horizontal curves. Road curvature and roadside obstructions, walls, trees, limit view. 3. Roadside structures. Buildings, bridges, guardrails may block line of sight. 4. Weather conditions. Fog, rain, and dust reduce visibility. 5. Vehicle design. Low driver seat height or high dashboards reduce visual range. 6. Traffic congestion. Vehicles in front may block view of upcoming obstacles. 7. Night driving. Limited by headlight illumination range. 1. Stopping sight distance, SSD. Definition: the minimum distance required for a vehicle to stop safely after seeing an obstacle on the road. Includes perception reaction time distance, distance covered while the driver reacts. Braking distance, distance covered during actual braking. 2. Overtaking sight distance, OSD. Definition: the minimum distance needed for a vehicle to safely overtake another vehicle without conflicting with traffic from the opposite direction. Longer than SSD due to additional space and time required. 3. Intermediate sight distance, ISD. Definition: a value twice the SSD, used when full OSD cannot be provided. Used in hilly or constrained terrains where providing full OSD is impractical. Significance of different sight distances. Type. Purpose. Significance. SSD. Ensure the driver can see and stop before hitting an obstacle. Basic safety requirement for all road types. OSD. Allows safe overtaking of slower vehicles in two-way roads. Prevents head-on collisions, enhances traffic flow. ISD. Provides better than SSD but less than OSD visibility. Used in space-constrained or cost-sensitive areas, Example hills. Thank you for watching the video.